Hello children. So as per the doubts of a student, I am explaining this question. This question pertains to your chapter, mm, your chapter light of science class 10th NCERT, right? Question number 6. What does it say? See, it says the far point of a myopic person is 80 centimeters in front of the eye. Okay. What is the nature and power of the lens required to correct the problem? Well, this theoretical part, most of you would know that what happens in myopic eye. See, basically, just remember, just remember that in a myopic eye, what happens? Let us take this as the lens, and this is the myopic eye. When from infinity the rays are coming, right? They converge in front of the retina, basically, right? When the object, when the light rays, or we can say the rays are coming from infinity, they converge here. Now, what is far point? Far point is the maximum point till which he can see clearly, right? So, basically, suppose what is given far point is 80 centimeters. So, from suppose 80 centimeters, if light is coming, then it can focus on the retina. So, this maximum distance is 80 centimeters given to us, right? Far point. Remember, in case of myopic, we say this is far point, and in case of hypermetropia, there is different near point, right? Myopic is short sightedness. So this is the maximum till length he can see, but he should be able to see till infinity like a normal eye, right? So what do? We place a lens here. What type of lens? Converging lens. Sorry, this diverging lens means concave lens. So what does it do? See, it shifts this. It is a see, it's a diverging lens. What it does basically is that suppose light rays are coming from infinity. Okay, means the object is at infinity if we assume. Then it diverges it, right? It diverges it little bit, and this diversion, after diversion, now it is formed at this retina, basically, right? So what happens? Basically, if the object, I'm saying if the object should be at infinity, then because of this blue, the concave mirror, it makes the image formation at this point, okay, at the far sightedness. Okay children, now consider one more thing. Isme kya hai? There are two lenses. One is your eye lens, convex lens, and this is a concave lens, right? So presently a combination is not in a course, but you have to consider only this case. Just think of it like, see this is the lens. We have to do something that we should be able, that the rays of the object coming from infinity should be able to converge, means it should be able to like come from this, means the image should be coming from here, right? From this, that is the far point. Okay, now see, it is coming like this. It will diverge a little bit more, and then when it finds the lens here, now it will converge to the retina. Okay, so basically now we have to consider only this case, because the numerical involved in this question, you'll get confused if you consider these things also. Okay, so just consider this one. Okay, just consider this lens. So what do you have to do? See, basically the object, you know the lens formula, that is 1 upon f is equal to 1 upon v minus 1 upon u. Fine. Now we need to know the focus. What focus, focal length we need? See, we know the far sightedness means basically this point. What is this? See, object, we know object distance u is infinity. 1 upon v is the image distance. Image distance, how much is the image distance? We know this as 80 centimeters, right? And it is to the left, same side as the object, means minus 80, right? And minus 1 upon u, infinity, take it positive or negative, whatever. So this becomes nearly equal to 0. You get 1 upon f 1 upon f is equal to minus 1 upon 80. This implies that f is equal to minus 80 centimeters, which you can write as 0.8 meters. Now the focal length is in negative. It means we are using a concave lens. Okay, Jiran, I hope the concept involved is clear. See, in this formula application, remember the power of the lens required to correct. If you look at the whole figure, you will get confused. You just have to look here, and only in this case, now I will highlight. See, this is basically the rays coming from the object. Where is the object? It is at infinity. Okay, now these rays should appear to come from this point, far point. Okay, so what do we put? We put a concave lens. Now the images appear to come from this point. Okay, so its object is here, image is formed here. Now children, this image as a secondary, it acts as an object for, आपको आगे ही बता देता हूँ, ये ऑब्जेक्ट की तरह एक्ट करता है हमारे आई लेंस के लिए. ठीक है, ये देखो इसका फिगर है, ये ऊपर ये वाला. नाउ इट इज एक्टिंग एज एन आई लेंस. अब यहाँ से ये रेज गई, थोड़ा सा और डाइवर्ज कर देता है, ये रेज इस पे गई, तो ये अब रेटिना पे फॉर्म आती है. ओके, I hope this concept is clear. Students, also if you have to calculate the power, see they have asked for the power of the lens required. So power, what is the formula for power? Power is 1 upon f in meters. That's why we have calculated this in meters. ये हमने meters में calculate करा है. That is equal to 1 upon, now remember this is minus, right? Minus 0.8. 1 upon minus 0.8, which is equal to minus 1.25. Now what is the unit? If this in meters, the power unit is diopter. Again, you know, negative power, it means it's a concave lens. Okay, chali, on this note we'll say thanks, goodbye, jai hind. See you next time.